My dear students, in this video I am going to derive Apollonius theorem, a theorem in plane geometry called Apollonius theorem. The theorem should be proved by vector method. The statement is, if D is the midpoint of the side BC, D is the midpoint of the side BC of a triangle ABC, prove by vector method AB square plus AC square mod of AB square plus AC square equal to 2 times of mod of AD square plus BD square. This is the statement of Apollonius theorem, and we are going to prove this theorem by vector method. Now, for this proof of this theorem, you consider A is the origin. Proof. Let A be the origin and AB, vector AB is vector B and vector AC is vector C. Since AB is the origin, AB is B and AC is vector C. Since D is the midpoint of the side BC, since D is the midpoint of the side, D is the midpoint of the side BC of a triangle ABC. D is the midpoint of the side BC of the triangle ABC. Then the position of the point D, then the position vector of D is AD, which is equal to AB plus AC by 2, that is B plus C by 2. Since D is the midpoint of the side BC, position vector of D plus position vector of C by 2, that is AB plus AC, B plus C by 2. Position vector of B is B plus C by 2. And we want AD square. For that, what is, this is AD. Similarly, we have to find out BD. And what is BD? BD is AD minus AB. AD minus AB. Since D A is the position vector, BD vector is AD minus AB. What is AD? BD vector is AD minus AB. That is, BD vector is AD. AD, you determine AD. AD is already we determined D plus C by 2 minus AB. AB vector is B vector. So by simplifying, you get this is B plus C minus 2 into B, 2B by 2, common denominator 2. So you get C minus B, 2B minus B, minus 2B plus B is minus B. Therefore you get C minus B by 2. This is your BD. Okay. B. So we want AD square plus BD square. AD square is, now we are going to find out AD square plus BD square. Right hand side I am considering this as Apollonius theorem. Right hand side AD square plus BD square. AD square is AD dot AD plus BD square is mod of BD dot BD. AD dot AD, you know, B plus C by 2 dot B plus C by 2. This is AD dot AD plus BD is C minus B by 2 dot C minus B by 2. Okay. C minus B. So B plus C into B plus C, this is 1 by 4 into B plus C into B plus C dot B plus C is B square plus C square plus 2 into B dot C. You know B plus C into dot B plus C whole square. That is B square B dot B square plus C dot C square plus 2 into B dot C plus C dot B, that is 2 into B dot A plus B whole square, like that. Similarly, this is 1 by 4 into C minus B whole square, that is 1 to 1 into 2 into 2, 4. C minus B is C square plus B square minus 2 into B dot C. Now, considering that 1 by 4 as a common term, you will get B square plus B square, 2B square plus C square is 2C square plus 2 into B dot C minus 2 into B dot C. Get cancelled. These two terms get cancelled. You will get this is plus 2 into B dot C minus 2 into B dot C. These two terms get cancelled. Therefore, you will get 2B square plus 2C square only. That is, you will get 1 by 4. If you take common, you will get 1 by 2. If you take 2 as common term in the numerator, 2 by 4 is 1 by 2 into B square plus C square. What is B square? Mod B square. Mod B square is AB square. So this is equal to 1 by 2 into mod B. B square is mod B, that is AB square. Mod AB square plus C square is mod AC square. You bring these two to the left hand side, that is 2 times of AD square plus BD square equal to mod AB square plus AD square. From this step, you can rewrite, if you bring this 2 to the right hand side, already you have AD square plus BD square. Less than 1 minute, I will erase here. See, you bring this 2 to the right hand side, it becomes 1 by 2 becomes 2 into mod AD square plus mod AC square, 2 into mod AD square plus BD square, sorry. Two into AD square plus BD square equal to mod of AB square plus mod of AC square. Hence the theorem. Hence the theorem. Hence the theorem. Theorem is proved. Okay? My dear students, the next theorem is altitudes of a triangle are concurrent. What do you mean by an altitude of a triangle? Altitude is nothing but the perpendicular drawn from the opposite vector to the opposite side. The perpendicular drawn from a side to the opposite vertex. It is called an altitude. Altitude is nothing but a perpendicular line drawn to a side from the opposite vertex. Like that, AD is an altitude, BE is an altitude, CF is an altitude. Altitude, there are 3 altitudes for a triangle. Each altitude is drawn from each vertex to the opposite side. Our idea is to prove that the altitudes of a triangle are concurrent. That is O is the concurrent meeting point of 3 altitudes. We have to prove that all the 3 altitudes passing through O. For that, I consider AD perpendicular to BC and BE perpendicular to SCA. Finally, we have to prove CF is also perpendicular to AB. If it is proved like that, all the 3 altitudes passing through the O, then they are concurrent. We know AD perpendicular to BC. We know that AD vector perpendicular to BC. Since AD perpendicular to BC, it means OA perpendicular to BC. This implies OA perpendicular to BC. Since O is the origin and A, B, C vectors are the position vectors of the vertices ABC. In triangle ABC, O is the origin. OA vector A, position vector of the vertex A is A, and OB is vector B. Position vector of the vertex B is B. OA is vector A and OB is vector B. Similarly, OC is vector C. Position vectors of the vertices with respect to the origin O are OA vector A and OB vector B and OC is vector C. Now, since AD is perpendicular to BC, OA is also on the line AD, therefore OA is perpendicular to BC. OA perpendicular to BC implies OA dot BC equal to 0. Because since these two vectors are perpendicular, the dot product is 0. You know OA is A. What is BC? BC is OC minus OB. BC is OC minus OB equal to 0. That is A dot OC is C minus B. OB is B equal to 0. OC is C, OB is B. This is by distributive law A dot C minus A dot B. A dot C minus A dot B equal to 0. You consider this is equation 1. Similarly, BE perpendicular to CA. BE vector perpendicular to CA. That implies BE on the line BE, OB is there, therefore OB perpendicular to CA. OB is perpendicular to CA. OB perpendicular to CA means OB perpendicular to CA. That means OB dot CA is 0 because the dot product of the two perpendicular vectors is 0. OB dot CA implies OB dot CA. CA means OC minus OA minus OC. Again, I write this step OB dot CA here. OB dot CA equal to 0. OB is B vector. Dot CA is OA minus OC. OA minus OC equal to 0. That is B dot OA is A minus OC is C is 0. That is B dot A is A dot B. This is B dot A minus B dot C equal to 0. You consider this is equation 2. Adding 1 and 2. Adding 1 and 2. What is 1? A dot C minus A dot B. A dot C minus A dot B plus B dot A is A dot B. You can consider B dot A is again A dot B because A dot B equal to B dot A minus B dot C equal to 0. Adding 1 and 2, left hand side, right hand side is 0. So plus A dot B minus A dot B cancel, you will get A dot C minus B dot C equal to 0. This implies A dot C minus B equal to 0. A dot distributive law A dot C minus B dot C is A dot C minus B is 0. What is A? A is OA. dot C is OC minus C, what is it? C dot, this is, I think it's not, sorry. C is common. A dot C minus B dot C is 0 implies A minus B dot C. A minus B, because common C dot. A dot C minus B dot C is A minus B dot C by distributive law. A minus B dot C is 0. A minus B is, OA minus OB dot C is OC equal to 0. OA minus OB is AB. OA minus OB is AB dot OC. AB dot OC equal to 0. AB, OA minus OB is AB. AB dot OC is 0. So OC is on the line CF. Therefore, AB dot OC is on the line CF. Therefore, AB dot CF equal to 0. We have to prove CF is perpendicular to AB. This implies CF is also perpendicular to AB. CF is also perpendicular to AB. So all the three altitudes are concurrent. Therefore, all altitudes are concurrent. See, since AB dot OC is 0 implies AB dot CF is 0, therefore AB is perpendicular to CF. So CF is also passing through O, therefore all the altitudes are concurrent. All altitudes are passing through O. That's all about the theorem. Okay? So far we have seen two theorems. One Apollonius theorem and the second one is altitudes of a triangle are concurrent. Okay, these two theorems are very, very important theorems as per the examination point of view. So my dear students, you get a clear idea about these two theorems. One is Apollonius theorem and another is altitudes of a triangle are concurrent. Okay, thereby I conclude this video and we will continue in the remaining topic in the next video. Thank you.